given a fixed point and a line. A collection of points that are equidistant from the fixed point and from the line is a parabola. In this case, the origin is a point on the parabola because the distance from the origin to the fixed point is p. The distance from the origin to the line is also p. So 0, 0, the origin is on this parabola. Similarly, if you can pick any point that satisfies such condition, for instance this point, the distance from this point to the given fixed point and the distance from this point to the line are the same. So this point is on the parabola. If we can obtain such a collection of points, then we end up with a parabola. If we pick any point on this parabola, the distance from that point to the given fixed point and the distance from that point to the given line is the same. And so if this point P, x, y is a point on the parabola, then the distance from P to F has to be the same as the distance of the line segment if we were to draw the line segment from the point P perpendicular to the given line. And we will call this distance PL for now. The distance from P to F is computed using the distance formula. The distance squared is x2 minus x1 squared plus y2 minus y1 squared. And so the distance from P to F is x squared plus y minus p, the quantity squared. This is the distance PF. The distance PL is a vertical distance, and so its length is the upper point minus the lower point. This is y equals y coordinate, and this is y equals negative p. And so the distance is y minus negative p, or y plus p. If we square the distance from P to L, then we would get y plus p, the quantity squared. But these two distances are the same, so we can equate the two. We should have x squared plus y minus p, the quantity squared. This is the distance from the point P, any arbitrary point P on the parabola, to the fixed point F. It has to be the vertical distance from that point to the line, which is y plus p, the quantity squared. Their distances are the same, so the square of the distances are also the same. And so this is the equation for the square of the distances, and again, they are the same. To find the equation of the parabola, we would need to simplify this equation. To simplify this equation, we will first expand this. The left-hand side is x squared plus y squared minus 2yp plus p squared. And the right-hand side is y squared plus 2yp plus p squared. So we can cancel out p squared and y squared. This is now x squared minus 2yp equals 2yp, or x squared equals 4yp. This is the standard form of a parabola. X squared equals 4yp. We say that the x-axis is the axis of this parabola. This parabola has the horizontal axis, and the vertex is at the origin. If p is positive, then this parabola opens upward. If p is negative, then this parabola opens downward. If we were to interchange the role of x and y to obtain y squared equals 4xp, then this parabola is now reflected about the line y equals x. Instead of opening upward, if we were to interchange x and y, then the parabola now opens to the right. And so for this new equation, if p is positive, then the parabola opens to the right. And if p is negative, then the parabola is now open to the left. And the vertex is still at the origin. X squared equals 4yp has a horizontal axis, therefore y squared equals 4xp has the vertical axis. The given point in the construction of this parabola is called the focus. The given line is called the directrix. And so given the focus and the directrix, we can construct the parabola this way.